Welcome to today's video, Unveiling Biases in RCT Designs, a comprehensive guide. In the next few minutes, we will delve deep into the world of randomized controlled trials, or RCTs, and shed light on the biases that may potentially influence their outcomes. We aim to equip you with the knowledge to discern these biases, understand their implications, and strategize to avoid them in your own research endeavors. Stay tuned as we begin this enlightening journey. Have you ever considered how biases can shape the outcomes of a randomized controlled trial, or RCT? How might these biases sneak in, potentially skewing results and leading us astray from the truth? Let's embark on a journey to explore this intriguing aspect of research design. In scientific research, bias refers to systematic errors that can distort the findings of a study. Different types of biases can creep into various RCT designs, each with unique impacts. Consider parallel group design. The most common type of bias in this design is selection bias, which occurs when researchers inadvertently influence the selection or assignment of participants to different groups. This bias can be minimized by implementing randomization techniques, ensuring an even distribution of participant characteristics across groups. Now let's turn our attention to crossover design. Here, the primary type of bias is carryover bias, where the effects of the first treatment carry over into the period of the second treatment. This can be controlled by incorporating a washout period, allowing enough time for the effects of the first treatment to wear off before starting the second. Factorial design, on the other hand, is prone to interaction bias. This bias arises when the effect of one treatment varies depending on the level of another treatment. To avoid this, researchers can analyze the data using appropriate statistical methods that account for potential interactions. In cluster randomized trials, or CRTs, we often encounter cluster bias. This happens when the characteristics of the clusters influence the outcomes. To mitigate this, researchers can stratify clusters based on certain characteristics before randomization. Stepped wedge design, a type of CRT, can be vulnerable to time period bias. This arises when external events coinciding with the timing of intervention implementation influence the outcomes. Researchers can avoid this by adjusting their analysis for time period effects. Finally, adaptive design trials bring their own type of bias, known as adaptation bias. This occurs when changes made during the trial based on interim analyses impact the final results. One way to minimize this is by pre-specifying the adaptations and the statistical methods to be used. In addition to randomization and blinding, other strategies to avoid these biases include using concealed allocation, implementing intention-to-treat analysis, and ensuring rigorous trial conduct and reporting. In summary, biases can influence the results of RCTs in many ways, from selection bias in parallel group design to adaptation bias in adaptive design. Each type of bias has unique implications and requires specific mitigation strategies. By understanding these biases and implementing appropriate measures, researchers can ensure the integrity and validity of their trials. This not only leads to more reliable results, but also contributes to the advancement of scientific knowledge. Remember, bias in research isn't a sign of dishonesty or poor practice. It's an inherent challenge that requires our constant vigilance and understanding. It's up to us to recognize these biases, understand their impact, and take the necessary steps to minimize their influence. Only then can we trust the results of our studies and continue to expand the frontiers of knowledge.